Hi, welcome. Today we're looking at exponential functions. Specifically, we're going to look at how do we write decay factors as rates. So looking at our previous formula, we notice we're going to be changing our b into a different form. It would be 1 plus or minus r, where r is our rate. So in this first example, we have 20, and then we have 1.05 to the power of x. And so we're going to try to rewrite this 1.05 as a rate. So from our formula, we notice that the b is equal to 1 plus or minus the rate, plus if it's growth, minus if it's decrease or decay. So in this case, since the b is 1.05, what do we add to it? To 1 to get 1.05? 0.505. So that means then that our r is going to be equal to 0.05. Now this is in decimal form. In percent form, this means that this would be a 5% growth or increase. Now, if it was less than 1, I'd have to subtract, and then it'd be negative. And in that case, it would be a decay or a decrease. So let's look at a few examples. In this case, we have our a, our initial value, is going to be 129. Our growth factor is 1.07. And since it is greater than 1, I know that this is a growth, which means I will be adding when I put my r in. So in this case, I would add 0.07 to 1 to get a growth factor of 1.07, which translates to a 7% growth. In the second example, a is 10. Our growth factor is 0.75. So this one's a little trickier, right? So that means to go from 1 to 0.75, I need to subtract 0.25, which means that this is a decay. And if r is 0.225, this is a 25% decay or decrease. Do one more example. In this case, our initial value a is 12, so it's starting at 12, but each time it's growing by 5/4. So 5/4 dividing 5/4, we know that is equal to 1.25. Since this is greater than 1, then we know that this is a growth. And in this case, I am going to be adding 0.25 to my 1. So this translates to a 25% growth. All right, that's it for now. Bye.